In this second video that looks at extracting and working with images in scan data, we're going to be using some data kindly provided to us by Navis. So it's not mobile mapping data in the sense that the scanners were mounted to a vehicle. In this case they are mounted to an individual walking around, and the SLAM routine then pieces it all back together again and gives you a lovely clean point cloud. So the images come in as normal, here they all are, and if I click on show image locations, you can see the uplighters now, and if I click on one of those it will jump straight to it. Okay, so here you can see we've got the point cloud overlaid, and if I were to turn the point cloud off you'll see just the imagery. I also have in here a project which I've started working on. Okay, so I've already started extracting the line work. Okay, and as before I can jump around and I can move to any location and see the survey interacting with the imagery. If I go out into the road over here, there we go. So if I click on this uplighter here, we can see that I've digitized some of the road markings. Notice I've got the yellow lines as nice thick lines. That's because I've used the line style in n4ce that actually draws a proper road marking line, and you see those because string shapes is turned on. If I turn it off you'll just see it as normal line work. Okay, now I've started drawing some of these manholes. Now obviously when we digitize we want to be sure that we are digitizing, if we're digitizing say a manhole, we want to make sure that we digitize exactly where we click. Now traditionally with a point cloud you can really only digitize in n4ce, or before this current version anyway, digitize where there's a point. But now if I go to digitize, so there is a new estimate plane tool which if we enable, it's currently set to default value of 50 mil, and you'll see that if I move over the scan data you get a little plane now. If I turn the point cloud off you'll see a bit more clearly. Okay, so that radius is controlling the amount of points that are used to plane fit. So if I was to just move over here and say look at the car, zoom in, you can just about make out that that is now sat on the side of the car. If I go on the side of the wall over here it's snapped to the wall. Obviously I don't want to do that, I want to use it for this manhole. So code MHR3, and all I need to do is just click where I want it. So I want to point there and here, and then finally over here somewhere. And there you go. We now have that rectangular shape, at least, exactly where we clicked. Okay, so that's when digitizing. Now you have the estimating plane tool as well as the normal pick tools now to help you click exactly where you want. You don't have to just rely on their point being there. Otherwise a lot of these were picked up using both 2D and 3D tools. So I digitized the curb and then I just paralleled it up in the 2D view, locking to the highest levels in that location, and same with the yellow line, just drew one and then paralleled it over the appropriate distance. Okay, so what I'm going to do now is I'm going to close that view down and I'm going to try and do some ground extraction for you. So I'll just turn my topo off just to make life easier. Enable the clipping box which I've already prepared, so you can obviously see all the scan locations there. One thing you can also do with the images is you can actually rename them. So if I drop one down you can actually hit rename and give them a different name. So if it's an important location you can obviously rename it as such so that you can find it more easily later on. And just another word on images, if I show you how they're stored, so now there's a new images folder off of the point cloud if the images exist. Okay, and then every image is listed in there. I found it useful because obviously the conditions on the day, and it's just a camera, isn't it, at the end of the day, so lighting conditions can vary, but I found if you download and use the free image processing tool called GIMP, it does a very good job of enhancing the stills, and obviously you can do it in batch mode, so you can do a whole lot at once. All cameras at the end of the day are subject to lighting conditions at the time, so some need it, some don't. It's just the nature of the beast. So back to this view here, all I'm going to do is start the ground extraction. To do that we're going to go to group by ground mesh, and I will add myself a new group for ground data. Okay, so that's going to be the target group at the end of the day, and I'm going to use a 1/4 of a meter grid with a 50 mil interpolation. Okay, it's quite important to have a tight grid, especially when you've got curves involved, because obviously they're not going to be very visible in a large grid, so you need to use quite a tight grid to try and pick them up. And we will press show through clouds so we can see the resulting mesh that it comes up with, and hit preview. Okay, so you can see the provisional surface it's come up with. It's not a particularly accurate model, it's just trying to guesstimate the underlying trend by using the data on the underside of the surface. Okay, so what we're going to do is we'll say use all the data that's within 150 mil of that surface. I've unticked use vertical distance, so we can try and use the diagonal perpendicular distance, to try and preserve some of those curves. I'm going to go into the ground data group and just hit classify. Okay, so now you can see that the count in the ground data group has gone up to 104 million. If I untick show through cloud and change it so it says intensity, we'll see it rendered, as opposed to everything else, such as the cars that have been left behind in the trees. Okay, if I right click, cancel the tool entirely, move over a bit, I think that's picked up. Yeah, we've got the curves in there quite nicely. Haven't got any cheese wedges cut out of them, so I'm happy with that. So I'll put that back to normal, turn off the original group, so obviously the cars and things like that disappear. Having done that, I'm now going to just turn this into an image, because then I'm going to use that later on to help me digitize from. So to do that, I'm going to go to Tools. I'm not going to use the Quick 8K, 4K, because they are actually not high resolution enough for a site of this size. So I'm going to do Export Image Tool, and I've got a preset size in here, 25K, which I've used before, so I know that's okay. I'm just going to bump up the pixel size to say 2, because otherwise we might end up creating an image with lots of white space. I'm going to hit Save, call it Topo for the time being, and just make sure it's saved to an ECW, because they are much faster than PNGs and TIFFs, and also much smaller. So press Save. There we go. So I've got my image. I'll just quickly check that worked fine. So go to Select, Images, move it over, press OK, and there we go. Okay, I had the scan locations turned on, so they've actually appeared in the image as well. Okay, so that looks good. So anything I want to do before I move on is to get a ground model out of this. So cancel that tool. I'm going to go to Point Cloud IO. Okay, so I'm going to create a ground model using a 0.5 meter grid spacing with a 100 mil search radius around that if you can't find the point is at the right place. With remeshing turned on, so a 1 meter edge length, and try that. Okay, so that looks okay. So if there were going to be any holes, the remeshing has made sure that that's been filled over. So that's good enough for me. So I'm going to hit Create Grid. Call this one Topo Grid. Nothing else needs to be enabled apart from Optimize. So okay, that. Right. So if I flip back to the project manager, go to the Topo. Okay, I'm just going to switch to a white background so it'll be easier to see. Okay, so my first port of call is to smooth these contours. So I'm going to go to DTM and select Smooth. There you go. So that's now tidied all that up. Now this surface I'm going to use here, this is going to be used to interpolate onto. Okay, so in a minute I'm going to create a more accurate road model, and I'm just going to use this surface now to interpolate from my topo. I could just obviously use these contours, but I want to show that we can actually use this surface to interpolate onto. It's much faster to interpolate onto this than it is the point cloud. So if I go to my topo, and if I turn off the point cloud temporarily, so you can see I've digitized in the paths. What I need to do is to infill with some spot levels. Okay, so the way I'm going to do that, under the design menu we have polygon fill, and I'm basically going to say that one, that one, that one, that one, and this one, for now at least. Okay, right click, and now it says indicate the origin point. So it's going to create a grid of levels for me fundamentally inside. So if I say that's my origin and that's my direction, and it says what spacing do you want to use and what do you want to interpolate onto. So I could interpolate onto the point cloud using the lowest levels, for instance, within that given search radius, but fundamentally I've already got that surface here using the lowest levels on a 1/2 meter grid, so I might as well just use that. So 2.5 meter grid, spot level code, press OK, and there you go. So that's very quickly infilled those areas with spot levels. I've got this area here though, obviously, with the paving stones in the middle. At the moment, if I was to model this, I'll just get straight triangles across there, which obviously is not good enough. So what I'm going to do is I'm just going to create some circles in the Cadd side of n4ce and then use those to drop some levels onto the surface for me. So if I go to the home, if I click on Cadd and DTM though, I see everything. So I'm just going to minimize the Cadd, minimize the model view. Okay, and I'm now just going to go to circles, and I'm going to choose 3 point, and let's say a point there, and a point over there. Okay, so there's one circle. And now I'm going to go to concentric sketched and say, oh, I want another one here, and then there, and then click again here, and then finally there. Okay, so if I close down the Cadd view, go back to my model view, there it is, and you can see if I turn off the backcloth, there are my circles. So what I'm going to do now is I'm going to go points, and I'm going to go generate from circles. I've got a code set up here which just draws a dot rather than crosses, and I'm going to say the height is going to come from, I could drop it onto the point cloud, but again I might as well just pop it onto the grid from there, and I point say every meter. So press OK. Okay, and in rectangle mode just click all of them. And if I were now to just turn off the Cadd with this tick box, you'll see all those dots. There they are. Okay. So if I now go to the Cadd backcloth, I'll just see those on its own. And now I can just press delete because I don't need them anymore. There we go. Move and update. Okay. So if I create the ground model now, I've actually got all of these in here to create my surface from. The road I'm going to do a slightly different way. So I want to create a hyper accurate road model just to show that we can do that. So if I close down this view, I'm going to go into a model here I've already got called road. Okay, so this is the edge strings that I've digitized. Okay, and then densified. So I use the densified command to then make sure I've got lots of points at regular intervals, because I want to make sure I pick up the surface accurately enough, because this is going to be my edge. So I digitized it and I went to lines, densify all, and then gave it the distance. Okay, and interpolated onto the point cloud. And now I've got that, I'm going to go into 3D on that. Okay, so here we have our road boundary. If I bring in the point cloud. Okay, so what I want to do now is I want to create a group of just that area. Okay, so if I go to add group, call this one road, and now I'm going to go to the tools, point cloud tools tab, and I'm going to say group by closed string. Pick the string. Okay, and what we're basically saying is original group is going to be ground data. We don't want to take it from any other group, only use the visible data, and we wanted to put it into the ground, into the road group, sorry, and press apply. Okay, so now that that's done, if I right click that just to test it, if I turn off ground data, that leaves us with just the road, which is what I wanted. So now to create a hyper accurate DTM, I can go back to point cloud IO, and instead of using 1/2 meter, I'm going to say 50 mil. And interpolate, say 20 mil. And put that down to 7.2 and hit preview. There we go, there's our ground model. Okay, there's a couple of noisy bits around the car which I can sort out in a minute. Otherwise, I think that's worked reasonably well. So I'll hit create, call this one road grid. Okay, so now if I just view the road grid on its own, zoom into these areas here, we've got a little bit of noise. So at the moment my contour interval set to 0.1, so if I go 0.25, we can start to see these noisy bits here. So I'm just going to go points, smooth by polygon. If I want to be certain of what I'm actually looking at, if I click on obviously select there, I can put the image over. Okay, so it's obviously just noise in that entire area. There we go. So you can still see there's a little bit of noise in the scan, because obviously it's just scan data, so I'm going to use the smooth operation on that. Okay, now that's done. If I just hit F5, if I just redraw, you can see now tidy up. If I go to 3D on that, if I was to change it now to height shaded, and obviously set the intervals more sensibly. There we go. And you can obviously start to see things like potholes show up. Sometimes it actually helps, rather than actually height shade things like that, you can, instead of saying height shading, you can say gradient shaded. If I change the limit to say 20, you can actually start to see the impression of the paint. There's the bike in the paint. And you have places like this popping up where there's obviously either noise in the scan or a pothole of some sort. I just want to show how we can digitize tree trunks. Okay, so there's the road on its own. So I'm just going to go to groups, obviously turn on the ground data, actually turn on that one as well. Right, so we can just see here that there's some stumps, some tree stumps. If I turn the clipping box off, you can see the whole trees themselves. Show the image locations. Okay, so if I have interest in digitizing this tree, for instance, here, I go to digitize. So I'm going to use a code TT, which I've already got set up. So if I go to cylinder picker, max radius, say 0.25, and say something like that. Okay, so if I do that, now under the circle finder, if I hit auto find, I can now just move it up and down. Okay, if this was a location where there was actually multiple stems, if I increase the size of the section, so if I say 3 by 3, and if I were to scroll it above this and zoom out, you see we've got this situation. Let's make it a bit smaller, 1.5 and 1.5. Okay, you can just about see that there's 3 stems here. Okay, if I go to multi-circle, it'll do its best to find them. And then I can say, well, I don't want anything stupidly small, so we can say nothing less than 50 mil, and it starts to clear them out. And then we've got the cluster radius here, which is basically how close points need to be until they're considered part of the same. So if I take away the max and put, say, 20 into the minimum, there you go. Okay, so it can very quickly dial out noise, update, there you go, we'll find them. But in this situation, I don't want to do that, so I'm just going to untick multi-circle and slide it down. And obviously the ground is where we want that to be, so we just choose pick height, click there, code set to TT. We've got the diameter in there as well already for us, so the ground level's been set, and you just press digitize. And there you go, you can see that's now appeared at ground level. Right, so to see how that can all be sort of pieced together and viewed, so if I click on this image location here, we're looking at the moment is just my topo survey. So what I'm going to do is, if I go to home, go to backlog status, I can bring in just the road grid. There we go. Obviously at the moment it's set so that it's overlaying the image. So if I were to change its opacity to say 20%, a bit much, say 50%, there you go, you can start to see through. Obviously you can see where the depressions are that way, or we can just change it to height shaded. But this obviously this view allows us to quickly move around and see how all our data sets interact all at the same time in the same view. That concludes this presentation.